Hello everyone. So today we are going to be talking about periodic table trends. Today your topic is periodic table trends. Your goal, I can draw periodic table trends and find the relative atomic radius, ionization energy, and electronegativity. So first off, we need to know what periodic law is. So Moseley came up with this law, or found this law, when he made his periodic table. A periodic law just shows a repetition of chemical and physical properties of elements when they are arranged by increasing atomic number. So you do need to make sure you type that out and you highlight the word periodic law. So basically, when you arrange it by atomic number, you notice there's a lot of repetitions in how they behave, and we're going to talk about what those properties are. So first off, just talking about the periodic table in general, which as we know looks like this. The first thing is the rows and columns. So periods are the rows of the periodic table, so it goes side to side, so like 1, 2, 3, 4, so on and so forth. Groups are the columns, or what goes up and down. So what does each of those mean for the element? So you can already draw some information for what we know. Groups 1 and 2 and 13 through 18. So 1 and 2 and then 13 through 18, so everything on this side, have a wide range of chemical and physical properties, and they are referred to as the representative elements. And then the ones in the middle, 3 through 12, those are called transition metals. And they kind of behave a little bit differently, so we'll talk about those as well. Okay, element classification. So elements are split up into 3 groups: metals, nonmetals, and metalloids. We're going to talk about each of those and what they mean. So first off, you need to know what a metal is. They are generally shiny and smooth when clean. They are solid at room temperature, and they are good conductors of heat and electricity. So you do need to make sure you type that out and highlight the word metals. Okay, if you look at the periodic table, your metals, let's insert. Is everything from here over plus what's in this staircase right here. So those are your metals. Take this out. All right. So the metals are on this side of the periodic table. There are several different types of metals. So you notice you have your alkaline metals, alkaline earth metals, your transition metals, your other metals, which is your aluminum, gallium, indium, selenium. So all of these right here. And then also you have your lanthanides and actinides. Those are also metals. So all of those tend to follow those properties of metals. Okay, so ones I just showed you. There are the alkali metals, which is group 1. They are soft, light, and extremely reactive. So in this first column. Your alkaline earth metals is group 2, which has a harder, denser, they're harder, denser, and stronger than alkaline metals, but they're still really reactive. So that's this column. Then you have your transition metals, which is group 3 through 12. So everything that's right here in the middle. And those form positive ions. They are reactive and they make colored compounds. That's where you find your gold, your silver, and all those. All right, so that's it for the metals. Now we're going to move on to metalloids. And what you need to know about metalloids, they exhibit properties of both metals and nonmetals. And they are found on a staircase between metals and nonmetals. So in this picture, it is the green. So you notice it follows a stair step right here. And those are your metalloids. They have some properties of metals and they have some properties of nonmetals. So you need to make sure you type that out as well. Okay, nonmetals. They have high electronegativities, poor thermal conductors, which means they do not transfer heat well at all. Poor electrical conductors, which means they don't transfer electricity very well. They are brittle solids. They are not malleable or ductile, which means you can't really make them into whatever shape you want easily. And there is little or no metallic luster, or they're not very shiny. Okay, so the different types we have for there, first are the halogens, which is group 17. So this one right here, your fluorine, chlorine, bromine, iodine, and the AT. And then you have your noble gases. So they do not react chemically with other materials and cannot be absorbed. Valence shell is full, which we'll talk about in the next video about what that means. They are in this last column. So that is your noble gases. Helium, neon, argon, krypton, xenon, and so on. All right, so now we're going to get into our trends. First trend is atomic radius. You do need to make sure you highlight and underline or type out atomic radius. And the definition that you need to know for that is it's the distance from the nucleus to the outermost electron, or basically the size of the atom. Okay, so if you think about it, as you go down a group, the radius will increase because there's more protons, neutrons, and electrons. But however, when you go across the period, the radius becomes smaller because it holds on to those atoms closer to each other. So if we were to draw arrows for this, the atomic radius goes down. And it goes across. So basically what that's saying is francium right here in this corner is the element that has the biggest radius. So it is the fattest element. That also means that helium is going to be your smallest one because it's in the opposite corner. So if I were to ask you, okay, which one has a bigger atomic radius, sodium or lithium? Well, it would be the one closest to this corner, so sodium would have the bigger radius. So if I asked you if sulfur right here versus calcium, calcium has the bigger radius because it's closer to this bottom corner. So whichever element's closer to this bottom corner has the biggest radius, atomic radius. All right, that brings us to the next trend, which is ionization energy. It is the energy required to remove an electron from a gaseous atom. So it's basically talking about how strong an atom's nucleus holds on to its electrons, or how strong that nucleus is. So you do need to make sure you need to type that out as well. Okay, the amount of energy to remove more than one electron always increases because the increased pull on the remaining electrons. The largest energy jump occurs when ionization occurs with the inner electrons. All right, so the trend for this, if you had to draw arrows, if you go across the top, it will point towards helium. And then if you go on the side, it will go up, also towards helium. All right, so the closer you get to helium, the higher the ionization energy is. Okay, so if we pick two elements, let's say neon and oxygen. Neon has the higher ionization energy because it is closer to helium. If we were to look at francium and cesium, cesium is the one closer to this corner, so it has the higher ionization energy. All right, so next, let's go to electronegativity. So electronegativity, the definition for that you do need to know, is it is the relative ability of its atoms to attract electrons in a chemical bond. So in general, electronegativity decreases as you go down, and it increases as you go to the left. Fluorine is the most electronegative element, and francium is the least electronegative element. So in a chemical bond, the element with the strongest electronegativity attracts the other and bonds electrons. So noble gases do not have any electronegativity because they are already happy with their electrons. They don't bond with anything else. They're loners. So this will look very similar to ionization up here, but there is a difference. So we'll draw our arrow across, but we'll stop right in front of francium, or fluorine, sorry. And then right above the electronegativity, let's see if I can find an X. We have an X right there. That is because helium, neon, argon, krypton, and so on, none of those will ever have electronegativity. And it also goes up. All right, so if we had to choose two elements, so fluorine is the one in this upper corner. It's the one with the highest electronegativity. So if we looked at copper versus calcium, copper has the higher electronegativity because it's going towards this corner. But if you are ever asked, let's say we have aluminum and we have neon. Well, neon's in this column with the X, so it will never, ever have more electronegativity than anything else. So aluminum has more electronegativity than the noble gases, even though they are closer to fluorine. And that is because of that X. So basically a summary of the trends. Ionization energy is the energy required to remove one valence electron from the atom. Electronegativity, which is how strongly an atom attracts the electrons in a covalent bond. Your atomic radius, which is the distance from the nucleus to the valence or outermost electron shell of an atom. And then your ionic radius, which is the distance from the nucleus to the shell of an ion. Now this one we didn't draw the trend, but it is basically the same thing as an atomic radius. It's just talking about when they are ions, which we will talk about later on in the unit, which is why I didn't really talk about it till now.